Hey, good morning or good afternoon, ladies and gentlemen. This is different, isn't it? Okay, here are the notes, the page of notes that you need to be on. If you're not there, pause and get there. Okay, here we go. So, two vocabulary, inverse operations and isolate the variable, two vocabulary phrases. Inverse operations. You already know this instinctually. But we're using them somewhat differently today. We're looking at opposite operations that undo each other. So you've thought before about, well, what's the opposite of multiplication? Division. And similarly, the opposite of division would be multiplication. And these could you use to undo each other to solve equations. That's the key that we need to know. Same thing with addition. What is the opposite of addition? That's right, subtraction. And if you're given a subtraction problem, the opposite will be addition. The other phrase that you need to know is isolate the variable. And that is a fancy way of saying to get the variable alone on one side. So it wants to be all alone on one side, all by itself. It's had a bad breakup. It wants to be all by itself. It's depressed. But what does that allow us to do? If we can use inverse operations to isolate the variable, then at the end we get an expression like this, an equation like this, x equals 1/2. It tells us exactly what x equals, and that's the goal, to isolate the variable. Y equals -3. It tells us exactly the value of y. All right, so let's do an example together. Determine which value of x is the solution of the equation. Now I know each and every person watching this can either logic this out or use guess and check to figure it out. That is what I no longer want you to do. And some of you will hate me for this, but you need to show your work. And you're just going to need to trust me that the ability to show your work now will determine your ability to show your work later in more advanced equations. Okay, so yes, you must show me your work. And for right now, you must show me your work the same way that I'm showing it to you. So the first thing I'm going to do under this flap is I'm going to rewrite the equation. X minus 4 equals 16. And now I'm going to think, what is the inverse operation of subtracting 4? Well, that's adding 4, right? That's the opposite of subtracting 4. So I forgot I wanted to talk about this. When you're looking at equations, you want to think about it like a scale. And what we want to keep it balanced. That's what the equal signs means, right? It means that whatever is going on over here is equal to whatever is going on over here. So if we had a scale, it would be balanced. So right now we know that x minus 4 equals 16. And as I just led you to consider, the inverse of subtracting 4 is to add 4, right? Well, so if we add 4 here, well, now our scale has gone wonky, right? It's going to be slanting this way because we have 4 more over here. So to even it out, we need to add 4 over here as well. And now our scale is balanced again, and we can then cancel, and we'll see, we'll get our variable isolated. So let's see what that's going to look like. So again, the inverse operation of subtracting 4 is adding 4. So I'm going to add 4 over here, but to keep it balanced, keep my equation balanced, I have to add 4 to the right side as well. I'm going to draw my line because now basically I've created a math problem, this expression and that operation. Well, so nothing is happening to x. I have no like terms to combine here, so I have x, just still one x. But now I'm combining these like terms. -4 plus 4 is 0, so we would say that they cancel out. Bring down my equal sign. I'm going to be working in a line always. And now I have 16 plus 4, and that is 20. So the value of x that is a solution to this equation is 20. It's the only number that will make this equation true. All right, so now we get to solve and check. All right, so what is the inverse of adding 8? subtracting 8. So I'm going to subtract 8 on the left side. And to keep my equation balanced, I have to subtract 8 on the right side. Draw my line. Now it's a matter of combining like terms. Well, x and nothing gives me x. Positive 8 and negative 8 together, whether I'm adding positive 8 and negative 8 or thinking about it as adding 8 and subtracting 8, two different ways to think about it. Either way, that's going to give me a result of 0, so I'm not going to write anything. I'm just going to cancel those out and write equals. And now I have 17 minus 8. That's going to give me 9. Now I want to make sure that my answer is correct. So I'm going to check. Yes, you need to show me this. And I'm going to do it the long way now. Your homework has it shorter. So I'm going to rewrite my expression, x plus 8 equals 17. Oh, but I'm going to add a question mark over the equal sign because I'm not sure if this value of x is going to give me 17. So now I'll substitute it in, and I'm always going to write it in parentheses. It seems silly, it's a small extra step, but it will help you out so much in the future. So get in that habit now as well. Because now I know if I'm adding or subtracting or multiplying or dealing with negative numbers, I'm going to be very clear. I'm substituting 9 in for x. Not 9 times something, not negative 9, but 9. Okay. And now I'm going to add 8, and I think that should equal 17, and sure enough, 17 does equal 17. Look at that. So I'm going to add a check mark here, and I'm going to go back over here, and I know my answer is correct. X equals 9 is a solution for this equation. All right. Pause if you need to. Okay. So go ahead and do the next one. Pause and work through it in your table groups. Are you ready? Okay. So right now, I'm either adding a negative 5 or I'm subtracting 5. Whichever way you want to think about it, doesn't matter. It'll work both ways. So I'm going to add 5 to both sides. Negative 5 plus 5 gives me 0, so I'll leave that blank. I'll just cancel it out. R plus nothing, well, it's going to give me R, equals 9 plus 5 gives me 14. So you can think about this as arithmetic going down, or you can think about it as I'm now making a new expression and I'm combining like terms. Either way, what do I need to do next? I need to check my answer. So negative 5 plus R, does that equal 9 with the solution that I have? Negative 5 plus 14, does that equal 9? 9 does equal 9. Look at that. So, yes, I'm being silly. R equals 14, checks out. That is our correct solution. Go ahead and work on the next one on your own. Pause if you need to. Ready? All right. So again, let's see, I have a negative 7, so I just had to add 7 to both sides. Negative 7 and 7 cancel, so I have m equals negative 11 plus 7 equals negative 4. That's an answer I'm not secure about, so I'm going to check it underneath. Negative 7 plus m should equal negative 11. Negative 7 plus negative 4 should equal negative 11. Do you see now why the parentheses come in really handy? And negative 11 does equal negative 11, so I am correct. Okay, on to a toughie. Solve and check. B minus negative 5 equals 11. I would work on this one in a group. You paused, right? Okay. So, there's two ways of looking at this. I'm going to show you one way and then I'm going to show you the other way. One way of looking at this is to rewrite the problem. If I'm subtracting a negative, I can add the opposite. So now I just have b plus 5 equals 11. Subtract 5 from both sides, I get b equals 6. The other way to look at it is to take it exactly with what's happening here. I'm subtracting a negative 5. What's the inverse of that? Adding a negative 5. And I'll add a negative 5 to the other side. Well, b plus nothing is still going to give me b. Subtracting a negative 5 and adding a negative 5. Those are inverse operations, so those cancel. And that equals 11 plus negative 5 gives me 6. Check my answer. My answer is correct. Okay, last one. Before you get started on this, I want to introduce you to declaring your variables. You are going to tell me what variable you're going to use and what it's going to represent. So in this case, the altitude of Mexico City in 2000 was about 7,350 feet above sea level. What was the approximate altitude of Mexico in 1900 if it sank 30 feet during the 100-year period? All right, so what are we going to do? We're going to declare A as our variable, and that is going to represent the altitude in 1900, our starting altitude. Why not the one in 2000? Because we know that one. We don't need a variable. Go ahead and work on that as a group. Come back and press play when you've got it. Okay, so the expression I wrote is A minus 30 equals 2000. The altitude in 1900, and it sank 30 feet, so minus 30 equals 2000. Did I misspeak earlier? I might have. Anyway, so inverse operation, the opposite of subtracting 30 is to add 30. So I'm left with A on the left, because negative 30 and positive 30 cancel out. A equals 2030. Now, did you check your answer? You should have. And sure enough, A does equal 2030. Okay, I want to go through one homework problem with you. It's on the second page of your homework. Yes, you have a front and back. Here we go. Josh is saving for a new bike. The bike costs about $78, including tax. Josh has already saved $42. How much more does he need to save? Let S represent the amount he is saving. Oh my goodness, I hate that, because what do you mean? The amount he's saving in total? Do you mean the amount that he still has to save? No, let's get rid of that. Let's rewrite that. Let S represent the amount he still needs to save. By the way, all the other word problems do not have variables declared. Make sure you define your variables. Okay, so I show my equation. I've got 42 plus x equals 78. So that's the 42 he has now, the s he still needs to save, and the total he's trying to save too. Use inverse operations. I'm going to subtract 42 from both sides. Yes, you need to show this work. 42 minus 42 is 0, so I'm just going to cancel those out. I'm left with s on the left. 78 minus 48 is 36. Check my answer. It's hard to read, but that's what it says. Check. So I'm going to substitute my value, my solution in for s. 42 plus 36 does equal 78. My solution is correct. Okay, I hope you guys have been awesome. If you do have work time left, I hope you use it well, and I will see you tomorrow. Have a great day.